Now.
Nope. Okay, now.
Alright, so a long time ago when they were trying to prove the theory of how gravity worked, they had a lot of weird theories of how it was, and the way they ended up proving how it actually worked was there was this guy who, this is actually a true story, some really rich philosopher who had a ton of money, giant house. He had like a balance beam scale, so it's a scale that hung kind of from a point right here. You put, one object on this end and one object on this end, and it would tip. So what he does is he puts like a 1 gram weight right here. So we'll just call that 1G. And then on this side you put, I can't remember if it's a 1 gram weight or some rocks or something to make the scale stay even and flat. So he had 1 gram on each side. He also had at the time the world's largest lead ball. That's true, it's really weird. But what happened is, so right now the scale is perfectly even. He pushed this lead ball under one side, and it was here. And lead, very dense metal, has a ton of mass. So this giant lead ball, a lot of mass to it. And what happened, he actually saw this scale, since it was such a long scale, it tipped down just a little bit, down about that far, and he noticed the scale tipped that way. And keep in mind, this scale is hanging up from something, so it's not like the weight shifted the whole foundation. The scale just tipped. Then he moved the weight to the other side, it tipped that way. So that's how they figured out how gravity worked. Now, the way the Earth, stuff can orbit the Earth, you look at Earth, that's Earth. It has a crazy mass. So gravity is pulled in. The farther away from something you are, the less gravitational force it has. So that's why when, they go up in space, the higher up they get, they start to lose gravity to eventually they're out here in 0G. Now, think of like a satellite, for example. If you just shot a satellite straight out into Earth and it just kept going, there's nothing to stop anything from moving in space. So if I was on the space station and jumped off, I would keep going. That's why astronauts have a pill of cyanide they can take if they fall and start drifting away, because they'll just be drifting forever unless they hit something. So Earth has a gravitational pull pulling everything in. So what these geniuses do when they launch a satellite out in space, they don't launch it straight out. They launch it out kind of at an angle like that. And what happens is it's a spinning object when it's launched out. And the gravitational pull pulls it in, but it also goes away. So if you think about it, this object goes out, then the gravity pulls it down a little. So it comes back in, then out and back in, and out and back in. So it's basically doing that around the whole Earth over and over again. Now if they got this math wrong, and they calculated the mass of what they're launching out into space and the velocity that's traveling wrong, and it was too close to Earth, it would go out, fall too much, and it would just go and crash down into Earth. If they did it too far out, it wouldn't fall down enough and it would just go away. So they have to get it right into the sweet spot, like that. And then
how do they find the sweet spot?
There's some weird calculations having to figure out how far away, you take, one of the formulas takes a number that represents gravity, and then you have to do some math and some equations to figure out how far away and at what velocity you need to launch the object for it to be affected by gravity and its velocity equally. Because you want the equation to basically equal 0 at the end.
So does gravity have like a certain weight to it, or
gravity changes the farther you are from Earth.
Right,
when you get really far away, it's not going to make a big difference.
Yeah.
So.
Ironically, those two equations up there are half of what they have to use.
Oh, is it?
The go, no go, yeah.
Well, there you go. So that's
Wow.
You need to know. But yeah, that's how that works. And I mean, everything has a gravitational pull. Like me and you, right now we have a gravitational pull toward each other, but it's so slight you couldn't even measure it with any equipment on Earth to figure it out.
Do atoms have their own gravitational?
Yes. So
every
atom has a gravitational pull. Every little thing, every molecule has a slight gravitational pull, but the larger the mass of a given object, the higher the gravitational pull to that it would be. So then you look at our solar system, you have the sun and the Earth, and then the moon. The moon goes around the Earth, and then the Earth goes around the moon, the sun.
Yeah.
And everything just kind of keeps going in circles like that. Cause everything is getting pulled toward the center. But the whole universe is also exploding at the same time. That's another weird thing. So yeah, astrophysics, that's the basics of how that works.